Hello students, welcome to grade 10 chemistry class atomic structure. In yesterday's class you have learned about electromagnetic spectrum. The spectrum, which is a continuous range of wavelengths of gamma rays at shorter wavelength to radio waves of longer wavelengths. Now in today's class you are going to learn about the reason for producing or for releasing these different types of spectrum. Why do they change? Why do these different types of spectrums are produced? Now let's get started. Before going to learn about the reason for producing different types of spectrum, just imagine that an iron rod is heated. Then some of the heat energy is emitted as light. You must have seen even an iron rod or something, a metal, when it is heated, slowly it becomes hot. So it releases heat energy, and this heat energy is emitted as light. So this is seen first in red color, and as the temperature increases, it glows to orange, slowly to yellow, blue, or even white color also. So here, when you are able to see a particular color, the other colors will also be emitted. Like at first, when you are seeing the red color, at that instance, even other colors are also emitted. But due to its higher intensity of one single particular emitted color, others cannot be emitted. So others cannot be seen. Other light waves are not seen. So this is known as per the theory, it was believed that it was a continuous spectrum, but when certain things were observed like heating and emitting of these different colors of light, Max Planck has broke with the continuous energy tradition. Till then all the other earlier scientists believed that this spectrum is continuous energy spectrum. So it is a continuous series of wavelengths. But Max Planck broke this tradition and he assumed that the energy is always emitted in multiples of h nu, where nu is frequency of the wave. So what change does Max Planck has brought is, when we imagine a body is radiating energy, it radiates means it emits energy continuously, and this energy is emitted in the form of a packet. So this packet consists of energy whose value is equal to h nu. So the energy can be calculated using the formula E is equal to h nu, where E is energy and h is Planck's constant and nu is frequency of the wave. It may be excuse me, it may be a red light wave or yellow light or anything, the light wave that is emitted. So what does this Planck's constant and what is its value? H is a Planck's constant whose value is equal to 6.627 into 10 to the power of minus 34 joule seconds, or 6.627 into 10 to the power of minus 27 earth seconds in CGS system. I repeat, Planck's theory. That is, before Planck's theory was proposed, other scientists had believed that electromagnetic spectrum is continuous energy radiating spectrum. But Max Planck broke this tradition and he assumed and proved that the energy from these is always emitted in the form of packets, which is known as quanta. And the value of this quanta, that is the energy, is calculated using the formula E is equal to h nu, where h is a Planck's constant, which means that energy of the quanta which is released is directly proportional to the frequency of the wave. So if the frequency of the wave is more, radiated energy is also more. So E is directly proportional to nu. And when this proportionality is taken out, h is inserted, that is proportionality constant is inserted. And hence h is known as Planck's constant in this equation, which is equal to 6.627 into 10 to the power of minus 34 joule seconds, or 6.627 into 10 to the power of minus 27 erg second. So this Max Planck quantum theory has brought a change in the energy of the electromagnetic spectrum. So what is the significance of Planck's theory is that electromagnetic energy can be gained or lost in discrete values and not continuous. So Planck's theory had proved that the electromagnetic energy, it can be gained or sometimes it can be lost. But this happens in discrete values, means in particular values, and it's not continuous. It doesn't happen continuously. Emission or absorption of light spectrum is collection of group of wavelengths. So here Planck's theory has brought to the conclusion that the emission or absorption of light spectrum is a collection of group of wavelengths. Now this led to the question that why do different elements different in color? While the elements are different in color. Then scientists found that the element emits its own characteristic color. Each element, it can be a sodium or magnesium or any element in that case. Each element consists of its own characteristic color. These colors correspond to certain discrete wavelength. So when I say sodium, it is sodium vapor. The light here, it is emitted in the form of vapors, which is yellow in color. So sodium vapors are yellow in color. And when I say magnesium, magnesium is white colored. This can be found when you are burning the Diwali crackers, mainly the pencil which you burn during Diwali time. So it contains magnesium. Sulfur, Diwali crackers contains even sulfur also. So here each element has certain characteristic color. So this color corresponds to a particular wavelength of it. So by identifying the color of the light, we can identify the wavelength. So when you are able to identify the wavelength, we can know the element also. So here, when these colors are corresponding to certain discrete wavelengths of light, these lights are known as line spectra because each is emitted in the form of lines. So here, this continuous spectrum is known as line spectra. So here in this slide, you can see the different colored flames. For example, if I say lithium, it is dark red in color. Then sodium, yellow in color. Potassium, violet in color. So in this way, different elements has its own characteristic color. So using the flame test color, we are able to identify the element that is emitting the light. So by observing the emitted light, we can identify the element also. So in this way, the flame test colors helpful to identify the element. Now, how does this Planck's quantum theory and flame test are helping is, we all know that basing on the observations of Democritus, J.J. Thomson, and then Rutherford's gold foil experiment, we know that an atom consists of subatomic particles, electrons, protons, and neutrons. So these elements are present in an atom, and these subatomic particles, protons and neutrons together, they are present in nucleus, and electrons revolve around the nucleus. And these electrons, when they are revolving, they revolve around the nucleus in their own orbits, like the planets revolve around the sun. So here you can observe that when this is the sun, imagining, and these planets are revolving around the sun, but in their own orbits they revolve. So in the same way, even electrons also revolve in their own orbits around nucleus. So this is the comparison between Rutherford's planetary model to solar system. It's similar to solar system, sun in the middle and planets around it. In the same way, nucleus in the middle and electrons around the nucleus. But the question that arises is when an electron is revolving around the nucleus here, it should not be stable because we have learned as per the Max Planck theory, Planck's quantum theory states that a moving object radiates energy. So when it is radiating energy, it can either gain or lose energy. So when it is gaining or losing its energy, it cannot remain in its own orbit. That is, for example, here in this atom, you can see that an electron is revolving in the orbit. So in this orbit, an electron is present, and in the next orbit also another electron is present. Suppose when these electrons are revolving, due to this movement of the electron, they release energy. And when they are releasing the energy, its energy is reduced. So it cannot remain stable in that position because the value of its energy or the strength of it is changing. Then planetary model has brought to a point that it should be more and more studied and modified. So the point that arises is the revolution of the electron in a circular orbit is not expected to be stable since it is not remaining stable. Either it is gaining energy or losing energy. So how can we complete or how can we conclude that this is proved wrong or experimental value has to be found is it is very well known that any particle in a circular orbit would undergo acceleration because whenever an object is moving, that too in a circular motion, when it is moving, it will undergo acceleration, which means that its velocity changes. Imagine that this is the position of the electron. So here it is moving around the nucleus, but when it moves forward, what happens? Its direction changes to downwards. So here there is a change in velocity, and which implies that acceleration of it has changed. So whenever a particle is changing its velocity, automatically it is get to be accelerated. So during acceleration, charged particles would radiate energy. So whenever a particle is getting radiated, sorry, is getting accelerated, it radiates energy, and that radiated energy is equal to h nu as per Planck's quantum theory. I repeat this point, make a note. A particle which is in a circular orbit, particle which is moving in a circular orbit would undergo acceleration, and during its acceleration it radiates energy which is equal to h nu as per Planck's quantum theory. So here you can observe, so an electron when it is moving, it is under acceleration and it emits, that is it radiates, it gives out energy which is equal to h nu. Thus, the revolving electron would lose energy and finally fall into the nucleus. So here, as per Rutherford's planetary model, when an electron is revolving around the nucleus, this revolving electron should lose energy and finally it should fall into the nucleus. But this is not happening. When it is falling into the nucleus, the whole atom should collapse. But it was not observed. If this were so, the atom should be highly unstable and hence matter would not exist because the atom collapses. But this was not observed, which means that planetary model has to be modified. So here, as the electron spiral inwards, means as the electron is getting accelerated in circular motion, it moves inwards, it moves towards the nucleus. The angular velocity and frequency would change continuously, and so the frequency of the energy emitted. So automatically it will change the frequency of the energy emitted. Thus they would emit a continuous spectrum in contrast to the line spectrum actually observed. So here when it is losing its energy, it should emit continuous spectrum. But it was observed that a line spectrum is emitted during the acceleration of an electron. What is this continuous spectrum and emission spectrum? Continuous spectrum means when light is dispersed from a source spectrum of continuously distributed colors on a dark background is known as continuous spectrum. When light is dispersed means when the light is spread from a source spectrum of continuously distributed colors is obtained. Where it is obtained on a dark background. This is known as continuous spectrum. Then what is emission spectrum? Emission spectrum is when a beam of light is emitted by a source and that is dispersed to get the spectrum is called emission spectrum. Here emission spectrum is produced by emission of light, and absorption spectrum is formed by the absorption of energy, and this energy is absorbed when electron jumps from lower energy level to higher energy level. So wherever during the acceleration of an electron, when an electron is jumping from lower energy level to higher energy level, it needs energy. So it absorbs energy. Like how we jump from one step to the higher step, we need more energy. So we absorb more energy and then jump. In the same way, the electron also, to jump from lower energy level to higher energy level, it absorbs energy and moves. So when it is absorbing, a spectrum is produced and that spectrum is known as absorption spectrum. If suppose the spectrum is released by emission of energy, then it is known as emission, and this happens when electron jumps back from higher energy level to the lower energy level. That is, when electron absorbs energy, it jumps from lower to higher energy level, and when it jumps back from higher to lower, it emits energy, and this energy is radiated in the form of spectrum known as emission spectrum. I hope you are clear here, or shall I repeat? Okay, I repeat. Continuous spectrum is produced when a source of light is released continuously on a on a dark background, then it is known as continuous spectrum. Whereas emission spectrum is produced or released when light is emitted. When electron jumps from higher energy level to lower energy level, light is emitted. This is known as emission spectrum. Then absorption spectrum. What is absorption spectrum? Is the spectrum that is formed when electron is absorbing energy to jump from lower energy level to higher energy level is known as absorption spectrum. Okay. So here you can see it's releasing energy. So by moving to the higher energy level, it absorbs energy and it produces the spectrum which is known as absorption line spectrum, because the spectrum is produced in the form of discrete lines, fine lines. Hence it is known as absorption line spectrum. Whereas here it is continuous spectrum, and this is emission line spectrum. When electron jumps back from higher energy level to lower energy level, emission line spectrum is produced. The person in this picture is Niels Bohr. Who is this Niels Bohr? Niels Bohr is a Danish physicist studied in Rutherford Laboratory since 1912. So he is Niels Bohr and he is a Danish physicist. He studied in Rutherford Laboratory. And what is his service that he rendered for the atomic model? Let's see. He successfully explained the spectrum of hydrogen atom and presented it as Bohr's atomic model. Niels Bohr could successfully explain the spectrum of hydrogen atom. So when emission spectrum, absorption spectrum, continuous spectrum were thoroughly aware, then Niels Bohr could study the spectrum of various atoms and he could explain the structure of hydrogen atom, and all his observations were presented as Bohr's atomic model. For this, he was awarded Nobel Prize in the year 1922. Now, let's see what is this Bohr's atomic model. Bohr's atomic model or Bohr's model of an atom. So as per this model, electrons revolve around the nucleus in definite energy levels called orbits or shells in an atom without radiating energy. So the first postulate or the first observation which was made by Bohr's model is electrons revolve. So these are the electrons, 3 electrons are present in 3 different orbits. These electrons revolve around the nucleus. This is the nucleus and electrons are represented here. These electrons revolve around the nucleus in definite energy levels. These energy levels, that is the circular orbits, are called as orbits or shells. And whenever these electrons are revolving in this, they revolve around the nucleus without radiating energy. And his second observation is, as long as an electron remains in a shell, it never gains or loses energy. What is the next point which he has observed and postulated is, whenever an electron is moving in a particular or in a definite energy level, those energy levels are called as orbits. And as long as electron is revolving in these orbits, its energy never changes. It doesn't lose its energy or gain energy. So its energy remains constant. The gain or loss of energy occurs within orbits only due to jumping of electrons from one energy level to another energy level. I repeat this point. The gain or loss of energy occurs within orbits. So the next observation which he has proposed is, an electron can gain or lose energy, and this can happen within orbits. Within the orbit only it can happen when an electron is jumping from one energy level to another energy level. That's what we have learned. Due to this changing of the energy levels, due to the change of electron from one energy level to another energy level, emission or absorption spectrum happens. That's what you can see here in the picture also. Plus H nu energy and minus H nu energy. So when an electron is coming from lower energy level to higher energy level, it absorbs energy and moves. And when it is coming back to its original level, energy level, then it radiates, it gives out the energy. Next point, the angular momentum of an electron is equal to nh by 2 pi. Angular momentum. What is this angular momentum? Momentum of a body when it is in linear motion is equal to its product of mass and velocity. But here the electron is moving in circular. It is under circular motion. So when it is in circular motion, here the velocity is angular velocity and hence the momentum is angular momentum. And now the angular momentum of an electron is equal to nh by 2 pi. What is the angular momentum of moving electron is, it is equal to nh by 2 pi. So he has observed and experimental value has also proved that the angular momentum of electron is equal to nh by 2 pi, where n is equal to the number of the orbit. It may be first orbit, second orbit and so on. So it is an integral multiple and h is Planck's constant. The angular momentum of an orbit depends upon its quantum number n. So when angular momentum mvr is equal to nh by 2 pi, it is purely dependent on h and n. But here h is a constant value, that is Planck's constant. So what is the variable is n. It may be first orbit or second orbit or any other orbit. So it is dependent on n value, and the angular momentum is equal to integral multiple of h by 2 pi. So equating this angular momentum, mass and velocity, since it is angular momentum, MVR, because its radius also must be in consideration. So MVR is equal to NH by 2 pi. Then these are the points which were observed by Bohrs. Now what is the application or what are the uses of Bohr's atomic model is the derivation of radius of an orbit of an atom. Using Bohr's atomic model, an angular momentum mvr is equal to nh by 2 pi. We can find the radius of an orbit. The next, derivation of energy. Energy value can also be derived for an orbit. The next is derivation of wave number. What is this wave number? Means number of cycles per unit length is known as wave number. So when we are telling that amount of energy that is radiated depends upon frequency, and frequency means number of cycles, that is crest and trough together is known as one cycle. So here the number of cycles is known as frequency, but wave number means it is equal to number of cycles per unit length. It may be unit meter or unit length of kilometer or anything, but wave number is equal to number of cycles per unit length. So using the Bohr's atomic model, we can derive even the wave number, means frequency can also be calculated. So automatically it gives the value of energy, and using the angular momentum value we can find radius of the orbit. So these are the applications of Bohr's atomic model. But it has its defects, it has its flaws. What they are, let's see. According to Bohr, the radiation results when an electron jumps from one energy orbit to another energy orbit. But he did not explain how this radiation occurs. So the first point is that the radiation of energy happens when an electron jumps from one energy level to another energy level. That is, from lower to higher. When it is jumping, energy is absorbed. And when it is jumping from higher to lower, energy is released. So here, this radiation of energy was explained, that is, it may be absorption spectrum or emission spectrum. But he did not explain how this radiation is happening, how this radiation occurs. So this is a drawback or a defect in Bohr's atomic model. The next defect is Bohr's theory explained the existence of various lines in hydrogen spectrum. So here Bohr's atomic model could explain the spectrum of hydrogen atom. Various lines were observed in the hydrogen spectrum, but it predicted that only a series of lines exist. So when Bohr's model was proposed, he completely gave the picture of hydrogen spectrum, and he predicted that this spectrum is continuous series of lines. But later on it was realized that the spectral lines that had been thought to be a single line was actually a collection of several lines which are very close to each other. So when Niels Bohr had studied the spectrum of hydrogen atom, he observed that the spectral lines are individual. It is a fine spectrum, fine lines. But later on it was observed that even the single line is also a group of several lines, a collection of several lines. For example, you can see here this red light is seen as single one, blue is seen as single one. So here all these blues together. So it is collection of several lines, which was not observed by Niels Bohr at that time. Then third drawback of Bohr's model is Bohr's theory successfully explained the observed spectra of hydrogen atom and similar ions, but it cannot explain the spectra for polyelectron atoms. So Bohr's model could explain only the spectrum of hydrogen atom. Hydrogen contains only one electron. So it could explain the structure of hydrogen atom and hydrogen-like atoms or ions, hydrogen-like ions like He plus 1. Helium 2, its atomic number is 2. He plus 1 means it has lost one electron and had become He plus 1. Then next is Li, that is lithium. Lithium's atomic number is 3. Here, lithium, when it is losing 2 electrons, then it becomes Li plus 2. So when it is losing 2 electrons, it possesses only 1 electron. So it is similar to hydrogen atom. So Bohr's theory could successfully explain the spectra of hydrogen atoms and hydrogen-like ions, but it could not explain the spectra of polyelectrons atoms. It could not explain the structure of atoms which contain more than one electron. The next drawback is if a substance which gives line emission spectrum is placed in a magnetic field, the lines of the spectrum get split up into a number of closely spaced lines. I repeat this. See, if a substance which gives line emission spectrum is placed in a magnetic field, the lines of the spectrum get split up into a number of closely spaced lines. So here it was observed that when a substance is giving line emission, when a substance is placed in a magnetic field, it was observed that it is emitting emission spectrum. But these spectral lines are getting split up into number of closely spaced lines. This phenomenon is known as Zeeman effect. Bohr's theory did not explain anything about Zeeman effect. So here in the picture you can see that magnetic field, when it is off, it is just shown as a single line. But when magnetic field is on, it has got split up into 3 different lines which are very closely spaced. When the magnetic field is off, they have become together and it is seen as a single line. So this process or the phenomenon of splitting of lines in the presence of magnetic field is known as Zeeman effect. Bohr's theory did not explain Zeeman effect. So this is another drawback. The next one. If a substance which gives the emission spectrum is placed in an external electric field. In the previous one, it was in the magnetic field. Now, when this object is placed in an external electric field, the lines of the spectrum get split up into a number of closely spaced lines. This phenomenon is known as Stark effect. So here, when a substance is emitting lines in presence of external electric field, then it is splitting into a number of lines. This process or this phenomenon is known as Stark effect. So when a substance is radiating spectral lines, if the spectral lines splits into its fine lines in presence of magnetic field, it is known as Zeeman effect. If it splits in presence of electric field, then it is known as Stark effect. But Bohr's theory could not explain neither Stark effect nor Zeeman effect. Bohr suggested circular orbits of electron around the nucleus of hydrogen atom. Bohr suggested that the circular orbits of the electron were around the nucleus, but later it was proved that the motion of the electron is not in a single plane but takes place in three-dimensional space. Bohr, when he studied, he felt that the electrons are moving around the nucleus, close to the nucleus also, around the nucleus, but later on it was proved that the motion of the electron is not in a single plane. It was three-dimensional along the length, breadth and in the height also. So in three-dimensional space, the electrons are moving around the nucleus. So here in this picture you can see that this is planar structure. So in a plane, when you imagine the motion of an electron, it is in circular motion. But it was observed that the electron moves in three-dimensional space, not only one space. It is three-dimensional space movement. So here in this way, like an electron which is green in color, for differentiation it is represented in different colors. So here this electron is moving in this way and the other one, blue electron, is moving along the height. and this electron along the breadth, it is moving. So it is in another dimension. So this is 1, 2 and the third one. So here it was observed later on that the motion of the electron is not in a single plane, but it takes place in three-dimensional space. Bohr assumes that an electron in an atom is located at a definite distance from the nucleus and is revolving around it with definite velocity. That is, it has a fixed momentum. Bohr assumed that the electrons in an atom are located at a different distance, like away from the nucleus at a certain distance in particular orbit. So he assumed that they are located at a different distance and revolves around it in that orbit with definite velocity, so which has a fixed momentum. But this idea is not in agreement with Heisenberg's uncertainty principle. So when he proved that an electron is moving in a stationary orbit or shells, it has a fixed momentum. But later on, Heisenberg's uncertainty principle. Later on, Schrödinger and Heisenberg had studied more and they proved that this fixed momentum of an electron in its orbit is not possible. Which means it is clearly says that uncertainty we cannot define. It is not certain that the velocity of it is fixed. So this idea is not in agreement with Heisenberg's uncertainty principle, which states that it is impossible to determine the exact position and momentum of a particle simultaneously with certainty. So here Heisenberg has proved that we cannot exactly locate and find the momentum of an electron simultaneously, not possible. So we cannot find them. This was not in agreement with Bohr's model. So these are the drawbacks of the Bohr's model. So in the next class, we are going to learn about how the drawbacks of Bohr's model were rectified. Okay. I hope that you have understood the Bohr's model and Max Planck's quantum theory also. So we'll be meeting in the next class with the other postulates which has rectified the defects of Bohr's model. Thank you.